All right, it's day 38. Let's get it. So today's question, I don't like such questions. I don't like bitwise shit. Minimize exclusive OR. Given two positive integers num1 and num2, find the positive integer x such that x has the same number of set bits as num2 and the value of x exclusive or num1 is minimal. Note that exclusive OR is the bitwise. Okay. Return the integer x. The test cases are generated such that x is uniquely determined. The number of set bits of an integer is the number of ones in its binary representation. Okay. Like, I clearly go blank when I see such questions. I literally have no idea. So maybe I can look into my notes. I don't know what's the I don't even know the website, man. I think it's on my channel. Let me just check real quick. Yeah, bigbraincoding.pages.dev. Here, bit manipulation, right? If you don't know what a binary number is, then don't read the rest. Okay. Ones complement. Flip all the bits of a binary number. Calculate ones complement. Add 1 to it. How are negative numbers stored in memory? Rules. Okay. Multiplication by 2. Yeah, arithmetic versus logical right shift. There are two types of right shift operators. Arithmetic right shift essentially divides by 2, shifting the bits to the right and fills the MSB with sign bit. Okay. A famous algorithm to find the number of set bits in a number. The main idea behind this algorithm is that when we subtract 1 from any number, it inverts. The main idea is that when we subtract 1 from any number, it inverts all the bits after the rightmost set bit. After the rightmost set bit. Okay, for example, the rightmost set bit. Yep. The rightmost set bit also gets inverted along with the numbers right to it. Yes, how can we count the number of set bits? Int count equals 0 while num Oh, what an algorithm. Num and num minus 1. So this will give me the number of set bits. How does it help with this question? Okay, x has the same number of set bits as num2. Okay. What? There will be some like fucked up solution to this question, and I okay. You know what? I am I don't know anything how to approach this. So I will look at the solutions. Most votes. Let's look at this guy. The problem revolves around modifying the number 1 such that it has the same number of set bits as num2, while minimizing the exclusive OR result of num1 and the modified number. What? The exclusive OR does it say to modify number 1? I mean, okay. Count the number of set bits in num2. Adjust the number of set bits in num1 to match num2 by either adding or removing bits optimally. Compact iterative bitwise manipulation. This approach directly modifies num1 to match the set bit count of num2. It counts the set bits in both numbers, iterates through the 32-bit positions. If num1 has more set bits than num2, it removes bits starting from the least significant set bit. What? Okay, we count the number of set bits in num1, we count the number of set bits in num2. If set bits num1 is equals num2, if it is less, then return self dot add set bits. What? Add set bits num1 and the difference. Remove set bits num1 and the difference. Add set bits. Bit position equals 0, while bits to add is greater than 0. While number is so the point is, why are we adding and removing bits from the least significant thing? Yeah, it makes sense, right? Because we have to do an exclusive OR with number 1 and we have to minimize that result. So we can't be flipping bits on the most significant side, because exclusive OR of that will be huge. That is why we are using least significant. Okay. Yeah, makes sense. Okay. Okay, let's write this. How do I get that back? Yeah. Okay, so first we write a function to count the number of set bits. We have to remove the least significant bit, right? And how do you do that? Yeah, that's what I was thinking. Okay. While n right shift by bit position is what means at that bit position, if there is a 1, how do we check that? By using this, right? If it is a 1, right, then bit position plus plus, because we need to add a bit at a 0 position, then n or 1 moved by bit position, right? Yep. Okay. Pretty weird question. I hate this topic actually, but yeah. I learned this today, so that's good. Okay, let's do one more question. Given an integer array nums and an integer k, return the k most frequent elements. You may return the answer in any order. Okay. K most frequent elements. Okay. Must be better than n log n, so it basically order of n, right? Nums of I can be a variety of range. K is in the range 1, the number of unique elements in the array. Okay, okay. Okay. So okay. One is to calculate the frequency of each number, right? And then put them in a heap or something, right? That is one solution, right? But that heap would take, I mean, it'll be log k, right? K log k, something like that. The point is, I have done this question before, and for sure multiple times, but still I'm not able to figure it out. Is that the solution? Like calculate the frequency, but okay, the number of unique elements can be many here, right? So that thing is pretty like space is a big problem here. Let's do something for this. Let's write or draw. Okay. K most frequent, right? K most frequent. I know nums of I range, right? Right. Now if I calculate the frequency of 1, this becomes 3, this becomes 2, this becomes 1. And I can keep a min heap, right? min heap of size k. So I can, like, on the go I can edit this shit, right? So when I encounter a 1, the frequency becomes 1, and in the min heap 1 is added, and k is what? K is 2 here, right? K is equals to. Now I encounter 1 again. I also need to keep a hash to check if this is in the fucking min heap or not. Okay, this seems long. Is there any clever solution? Should I just look? Because these questions are fucking... I don't know, man. Let's look at my past solution. What I did November 17, so over a year ago. This is the fastest thing that I did. Code, what did I do? Bucket sort. What the fuck is this? So frequency didn't default. Okay, I calculated the frequency of all, and then in bucket sort, list integer bucket, new list nums dot length plus 1 for integer k key in frequency dot key set. I got the frequency. If bucket of frequency is null, then add new list and add key. So we are hashing the key to where key is the number. Then get first k. Int result equals new int k, j equals 0. And what is bucket? Nums dot length plus 1. List. Okay, a list of list. I didn't understand shite from this solution. Let's take a look at the C++ solution. This is slow as fuck, right? What is bucket sort? What the fuck? So first we are calculating the frequency, then we create a list of lists of nums dot length plus 1, right? Then for every key in frequency, I get the frequency, bucket of frequencies. Then for that frequency, okay. Frequency, and the max frequency can be this, right? Makes sense. Then we go from the back, bucket dot length plus minus 1, and j is less than k. I think j is just a counter. Bucket of I is not equals null for int n and bucket of I. Brave result of j equals and j plus plus, yeah. Okay, I got it now. How is this fast? Oh, we are not sorting here. That's a good. Okay, I got it. So first of all, we calculate the frequency, right? I need a new keyboard, man. Frequency dot what? Put, right? right? Yeah. Then bucket sort. List. Basically, we are putting all of the numbers which have the same frequency in one bucket. That is the logic. Bucket equals new array list of size nums dot length plus 1, right? The maximum frequency possible is nums dot length, right? Plus 1. Why we are doing this? Because we need to store the max frequency in an index, right? That's why. Then for how do you traverse over a map? Frequency dot key set. Okay. For integer key frequency dot key set count if bucket of count is null, then should I do get? The fuck did I just do? Right? Then what do we do then? For integer key in bucket of I do I need to add a null check here? If bucket of I is not equals null, then for integer key in bucket of I, result of j equals key j plus plus, right? If j becomes k, then return result, then break, right? And in here we also add a condition. Okay. Bum 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 bum. Okay, why is it 0? Why is it 0? Bum, 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 bum. Key. Count. The fuck? Frequency.keyset. Right. Nums.length -1, I is 0, I is greater than equals 0, and j is less than k. Yup. I minus minus if bucket of I is not equals none. Oh shit. Should be this. Yeah. Is it done? Yeah. Alright. Good question. I mean, yeah, interesting. Alright, so this was enough Leetcode for today. I'll be back tomorrow because we crush all weekdays. So yeah, this was it for today. I'll be back again. GG's.